Okay, so let's move on to solve the challenge problem of chapter 19. Okay, so it's about the log. So the first problem, okay, is this. So when we take off the log, we do the leftmost first. Okay, then it's the same thing like when we do the fx, then f of the fx equals something. Normally we take out the left first. Okay, we do the fx equal to f negative of the circle. Then we do the second one. Okay, the x equals to f negative of the circle. When we take off the log, we also do the same thing. So now let's see the log 2 of this, right? So you can see the log 2 of the x will be equal to the 2 to the power of 2, right? Then we take this one will be another 2 to the power of 2. We take this one will be another 2 to the power of 2. So 2 to x equal 2 to the 2 to 2. Now let's do this one first. It's 4 is equal to 2 to the 4. Now let's do this one first. It's 2 to the 16. The 2 to the 16 is, so it's 5 digits. Next. So I invest all of my money in investment, pay the same annual compound. The compound interest means, okay, when you have an investment, when you have an initial value of the I0, and let's see the ratio is the compound ratio is R. Okay, so after first year, okay, first year you will have I0 1 plus R. Okay, the second year, all this will be the new principal. Okay, then the second year you will have the I0 of 1 plus R square. So after nth year, you will be I0 1 plus R times n. Okay, so you can see this one is like, if this one is like an, right? So this one, it will increase exponentially. That's why the compound investment is a huge return if you do it in the right way. Okay, so you can see the interest rates for 30 years, and at the end of the first 10 years, my investment double, means I0 times the 1 plus R of the 10 years equals to the 2I0. Okay, so after how many years original I can become 4, right? So I want to see I0 1 plus R of the n years will be the 4 times I0. So it will be 2 times the 2I0, right? So every 2 years is every 10 years is double, right? 1 plus R to the 10, 1 plus R to the 10. So you can see after 20 years, you will be quadruple. Okay, now the B. So you can see my initial investment is 5,000. How many for the 30 years, right? So I0 is 1 plus R for the 30. So we have 3 of the double, right? We double 3 times, 1, 2, 3. So it will be 8 times 5,000. It will be $40,000. Next. So we want to find the domain and the range of this one. Okay, so the domain of this one means the x squared minus 4x minus 5 need to be greater than 0. So then you can see it's the x minus 5 and the x plus 1 need to be greater than 0, right? Since this is the parabola, that curve is up, opens up, right? So this is -1, and this is the 5, and the center is the 2. It's something like this, right? So you will be positive number. So you'll be from the negative infinity to -1, not inclusive 1, and union the 5 to the positive infinity. Okay. So what is the range of this number, right? So you can see the range of this number is 2 log something you can go to y goes to infinity, and this one also goes to infinity, right? So the fx can goes to very close to 0, you can go to negative infinity, and go to infinity, you can go to infinity. So this is the range of this function. So find the domain and the range of this function. So this function, actually the only thing we want to the domain is this one cannot be equal 0, right? So you can see the 3 of the x will be greater than 0, less than infinity, so that's why the 2 plus 3x will never equal to 0. Okay, so you can take any x is okay. Okay, then what's the range? So now you can see 2 plus 3x, right? 3x is can approaching 0 but can never, it's always less than 1, and it's less than infinity. So the fx is should be greater than 0, right? And less than the 5/2. So for this one, the graph shows on right is the equation of the y equal fx, where the fx equal log a x b. Okay, so let's see the log a x b. First is the 0, right? So we know log a of the 1 equals to 0, right? So we know when x equals 2, the b times the 2 equals 1. So we can see b equals 1/2. Okay, the second one is the 0.1 is the case. Okay, so when b times, this is a 1, 2, 3, 4, 5, 6. b times 6 equals 1, right? So because the equals a, because the log a equals 1, right? So now you can see when x equals 6, it equals to a. So that means the a equals the 1/2 times 6 is 3. So a equals 3, b equals half. So next, okay, so let's rewrite this one here. Okay, so we know the 4 to the 2x over 4 to the 3, right, equal this. So it is the 64, then 2 to the x, then over the 4. Okay, now we know this one, right, is 2 to the 3 of the x equals 27. Now we know the 2 to the x is equal to the 3. So we know 2 to the x equal to 3, so it's 3 to the 4 over 64, so it's 81 over 64. This is the answer. Okay, so this one, okay, we have, yeah. So I copy the picture, I cut some picture out. So we know this one equals 8. Let me write it here, okay? And the 9x plus y over the 3 of 5y equals the 243. Okay, so this one is 2 to the 3, and this one is 3 to the 5. Okay, now let's calculate. So this one is 2 to the 2x minus x minus y, right, equal to 2 to the 3. This one is 3, the 2x plus 2y minus 5y is equal to 3 to the 5. So we have two equations, is x minus y equals 3, and 2x minus 3y equals 5, right? Now you can simply solve the equation. After you solve the equation, you get x equals 4 and y equals 1. So next, so evaluate this one, right? Log 2 to the 3 is equal to 3. Log 2 of 2 to the 4 is equal to 4. Log 2 of the 2 to the 3 times 2 to the 4 is equal to 7. C is log 3. 1 over 3 of 2 is equal to negative 2. Log 3, 1/2 is equal to half. Then log 3 and 3 negative 2 and 3 1/2 is equal to the negative 2 plus 1/2 is equal to the negative 2 3 over 2. Okay, that's B. And C, yes, and this is easy, right? So you can see the log A of B is equal to P, and log AC is equal to Q. Then what you can get is P equal to A to the B equal A to the P, C equal A to the Q. Then B times C is equal to A to the P plus Q. Then you can see the log ABC is equal to the P plus Q. Okay. Next is Alice invested some money at the annual compound of the rate. B invests the same amount of money. So that means AX is equal to some compound ratio, is invest some money of I0 and 1 plus R of the N, X years, right? And B, Bob invested some in the simple interest, means Bx equal to I0 and 1 plus after X years is X times S of this. Okay, so after 10 years, they are worth the same amount. Okay, so that means this. Okay, so the Alice compound ratio will be like exponential. Okay, this is the starting, it's all I0, right? I'm sorry, we shouldn't draw this part. Let me oh, sorry. Okay, because we're starting the year, so this is the X year, right? They all starting at I0. Okay, and this is the Bob. So after 10 years, they are equal. X equals 10. They are still equal, right? At the beginning, they are equal. So this is the Alice, this is the Bob. Because exponential increase much faster, right? So for the 11th year, you can see the A11 should be greater than the B11. Okay. Next. So this one, okay, well, looks like, but be patient, okay? Take a look at this common things, okay? Let's take out the x98 and the x squared minus 4x. Minus the x squared minus 4x is equal to 0, okay? We want to see number of the real roots. So x98 minus 1 and the x squared minus the 4x is equal to 0. Okay, so the first part is this one. X98 minus 1 equals 0. X is negative 2. So I have two answers here. And this one, let's draw the picture, the second part. So y equal x squared. And this one exponentially fast. So you can see we have 1 point here, 1 solution, right? So I have another 1 solution here. So in total, I have 3 solutions. Okay, so yeah, that's it for the challenge problem for this chapter. Thank you.